Let's make a world map. This is the world map that we're going to create. We'll discuss world atlas data sources, TOPOJSON and GEOJSON, loading data from a CDN using topojson-client, libraries with package.json, blocks.org and its clone, searching D3 examples, the D3 Geo package, rendering geometries and graticules using SVG, and various map projections. Let's make a map of the world. I'll start by forking this scatterplot simple example. I'll call it world map simple. And then the way I'm going to do this is modify this code so that instead of loading data.csv and rendering it as circles, it will load some data that represents the shapes of the countries of the world, and it will render those using SVG paths. My first step here will be to delete data.csv, the iris dataset. And then let's take a look at this topojson/world atlas project. This has been used as the data source for most D3 world map examples. This project provides a convenient redistribution of natural Earth's vector data. And natural Earth is a really nice public domain map dataset. Natural Earth provides these downloads of this data about the shapes of countries in these sort of standard formats for geographic data. These are pretty large files though, and not really suitable for use in the browser. This project represents the same data as TOPOJSON, which is a very efficient file format. Let's take a quick look at the TOPOJSON project. TOPOJSON is an extension of GeoJSON that encodes topology. That means it stores shared line segments, and so it doesn't duplicate those lines like GeoJSON does. Now let's take a quick look at GeoJSON. GeoJSON is a format for encoding a variety of geographic data structures, and it looks something like this. These objects have a type field and also a geometry field and some properties that contain metadata like country names. GeoJSON is actually a web standard. It's a standard specification. The task before us is to load in this World Atlas TOPOJSON data into our viz. Unfortunately, this project, a project by Mike Bostock, has been archived recently. But I'm pretty sure there's an active fork of this. Yeah, Vision's Carto World Atlas. This is a project by Phil, who is sort of a renowned contributor to D3 and maps in particular. This is a modification of the original project with various improvements. Because this is published to NPM under this name here, we can actually download the data into our viz from a CDN like Unpackage. We can just drop this name at the end of this URL and put a trailing slash to explore the files. And here we see that there's a directory called world, and there are two relatively small files. This is the higher resolution version, and this is the lower resolution version. I think I'll download the lower resolution version for now. And if I click View Raw, we can see the raw TOPOJSON data, and we also get this URL that we can use in our code. Here in viz.js is our older code that was fetching the data from data.csv. Instead, what I can do is make a variable called world atlas URL, and I'll define world atlas URL to be a string that contains that URL from Unpackage. Now that we're fetching that URL, we don't want to get the text out, but rather we want to parse the JSON from the response. And instead of getting a CSV string, we're going to get something else. I'll call it TOPOJSON data. And for now, all the rest of this is not relevant. So I'll comment that out, and then let's see if it worked by saying console.log TOPOJSON data. And sure enough, there it is. We get this object. Now that we have this TOPOJSON object, the task at hand is to transform this from TOPOJSON into GeoJSON. This is what the TOPOJSON-client library does. In particular, we need to use topojson.feature. But first, we need to get access to this TOPOJSON-client library. Ideally, I would like to be able to say import TOPOJSON from TOPOJSON-client. This is how you would do it if you are using a build tool like Vite or Webpack. But keep in mind, we are in this VizHub environment that sort of tries to emulate that setup. We are pulling in D3 from a CDN, and then VizHub has baked into it support for using this import syntax from the D3 package in particular. But as soon as we want to introduce additional libraries, we need to adopt the package.json feature of VizHub. So what I'll do is create a new file called package.json. And let's take a look at this existing React and D3 starter example that also uses this same feature. Package.json is a file for NPM packages. So it's sort of a standard thing in the Node ecosystem. Its primary purpose is to let you specify dependencies for your project and their versions. You can also use it to specify which license your code is released under. Under the hood, VizHub pulls these libraries from a CDN. But to make the import syntax work correctly, we need to tell VizHub which global variable to use and what path the file is within the CDN. This example here shows how we configure D3, React, and React DOM, but this can be applied to any third-party library. So let's apply this to TOPOJSON. I'm going to copy this whole file and then paste it into our package.json for our simple world map. I'll remove React DOM and then change React to be TOPOJSON-client. And let me check what version the current version is. You can check the current version of a package by taking a look at its page on NPM. That displays the version right here. So I'll use that specific version, 3.1.0. And when we adopt this package.json feature, we no longer need to pull in the script tag from the CDN ourselves. That's done under the hood. But I do want to make sure we have the latest version of D3, which is 7.8.2. So I'll paste that version here. I know this configuration here is correct. It looks for the D3 browser global, and it looks to /dist/d3.min.js for the file that contains the library. But for TOPOJSON client, I'm not quite sure what those are. To find out, let's take a look at those distribution files. I'll type unpackage.com/TOPOJSON client and see how it automatically redirects to /dist/topojson-client.min.js. That's what we can use here for the path. And we can see here that it defines the browser global called TOPOJSON. So that's what we can put here. This is how you can configure VizHub to load an arbitrary third-party package. Now let's check if this import worked by saying console.log TOPOJSON. And indeed, we get this object with these various methods, one of which is feature. TOPOJSON.feature is the method that we want to somehow invoke with our TOPOJSON data. And that's the thing that can become our data that we store in our state. So I'll just uncomment that right now. But I'm not sure if this invocation is correct. The documentation says TOPOJSON.feature returns the GeoJSON feature or feature collection for the specified object in the given topology. If the specified object is a string, it's treated as topology.objects@object. This documentation is great and all, but when it comes to figuring out how to actually invoke this stuff, there's nothing better than a reference example. My favorite way of looking for reference examples is searching blocks.roadtolarissa.com, which is an open source clone of blocks.org, which is a simple viewer for sharing code examples hosted on GitHub Gist. Blocks.org was unfortunately taken down recently. That's why we're looking at it in this archive of the page. But when it was up, for over 10 years, it served as, the de facto place to look for awesome D3 reference implementations. Even though blocks.org is no more, there is this open source clone by Adam Pierce that you can actually search with Google by saying site:, paste that URL, and enter a search term like world map. And this actually works fairly well. See, it gives us this world map 6 by Nitaku. This is an awesome example of a world map. And if we take a look at Nitaku's profile, we can actually see the progression from a simple world map to a more complex world map, adding labels and adding color, and finally culminating in this epic map of world population. This is one of my favorite examples of all time. I think it's really well done. It shows circles on a map and tooltips based on the population of each country. And these circles are not overlapping, and I think it's a force-directed layout algorithm in play here. But let's go back to the simple world map right here. We can study this code to figure out how to invoke TOPOJSON.feature. Okay, so similar to our code, this older code pulls in the TOPOJSON file, which is called geodata, using d3.json, which is a utility for fetching JSON. And then it calls TOPOJSON.feature, passing in the top-level object, and then as the second argument, it passes that object .objects.countries. And like we saw before, if the specified object is a string, it's treated as topology.objects@object. Therefore, in our code, we should be able to pass countries as the second argument here. Because when we do console.log topojson data, we see this object that does have a property called objects, and on that object it does have a property called countries. It also has another one called land, which I guess is just the merging of all the countries. To see if this works, I'm going to console.log data. And there it is. It's a feature collection that looks like valid GeoJSON. All right, that's how you use TOPOJSON to parse a TOPOJSON file into GeoJSON. Now we can go ahead and delete this old dead code, clean things up a bit, and now we can finally think about rendering this data from our state. Previously, this code invoked a scatterplot component passing in the data and all these other properties, which are now irrelevant, so I'm going to delete those. And now I would like to invoke a map component instead. Now at the top of the file, we are importing scatterplot, which I'll change to map. I'll also rename this file from scatterplot to map and update its export from scatterplot to map. I will delete these values that we don't need. I will also delete the code to do with scales and the code that sets the circle attributes. This is pretty much the structure we want. However, instead of circles, these are going to be path elements. And then we want to set the D attribute to be a function of, I'll call it D, that's going to be the GeoJSON object that represents one country. Actually, let me just first check if that's correct. Console.log data. Data is actually an object that has a field called features. And features is the thing that has an entry for each country. And we can see here the country name, country ID. So actually what this should be is data.features. And then we have to figure out how to implement this function. This is where D3Geo comes in. D3Geo contains various geographic projections and utilities for working with them. Here's a pretty simple example that imports this equal Earth projection and the GeoPath utility. It then instantiates the projection and instantiates this path generator using that projection. This path generator is a function that takes as input a GeoJSON object and returns one of those SVG path strings that we can use as the D attribute. So let's pull this into our code. Instead of importing extent and scale linear from D3, we can import these things from D3. And then we can use path of D as the value for the D attribute of our SVG path. And there it is. There's our world map. All right, that's how you can use D3 and TOPOJSON to render a basic map of the world. I want to show you just a couple more things to make our example more similar to this example. The first thing I want to do is add a stroke to our outlines so we can see the separation between countries. For that, we can just set the stroke to be white. And to make those lines a bit thin, we can set stroke dash width. I'll set this to 0.5 pixels, which gives a kind of a nice, more muted effect. Next, I want to add these lines here, which are called graticules. For that, we can use d3.geograticule. Let's import geograticule from D3, make a variable called graticule, which is an instance of d3.geograticule, and then we can make a new path, and this will be just a single path. So we can use the pattern we've used before, just pass an array of null, and the D attribute of this path will be path of graticule invoked as a function. And the second block is clobbering this first one because it selects on paths. So let's make it more specific by giving this one a class of graticule, both in the selection and as the class attribute. And we need to also give these paths a class of, let's say, countries. All right, we've got this crazy looking thing that is rendering our graticules, but it is actually filling them in. To fix this, we can set fill to be none, but we still want to see them as lines. So we can set stroke to be, let's say, gray. And there we have it, graticule lines. I'm going to set these to be thin as well, and maybe a slightly lighter shade of gray. hash FFF is white, and the lower we go, like DDD, the darker those lines become. So let me try BBB. Okay, I like that. We have pretty faint graticules. The only thing missing now is this outline around the whole thing, which comes from graticule.outline. I'll add that by copy-pasting that whole chunk, giving it a class of outline, and setting the D attribute to be path of graticule.outline. And to make it a bit pronounced, I'll set the stroke to be black, and I'll set the stroke width to be 2 pixels. All right, we have a pretty decent looking world map. The last thing I want to show you is that Geo equal Earth is one of many map projections. These are all listed in the projections section of D3Geo. We've got azimuthal projections. I don't know if I'm saying that right. Gnomonic projections. Orthographic, this is the one that makes it look like a globe. And if you want to use any of these, just import it from D3 and use it as the projection. Now we get a globe. There's some really cool and wacky projections in here. GeoAlbers USA is specific for the US. And GeoMercator is one of the most popular projections, although it does have a fair bit of distortion. Natural Earth also has its own projection, which is designed to be appealing to the eye for small-scale maps of the whole world. I think I'll use that one. All right, that's how you can use D3, TOPOJSON, and all that stuff to make a fairly decent looking map of the world, including graticules and the outline.